What if I told you that 6 simple fractions, just one side divided by another, are powerful enough to map the stars, guide missiles, and render every 3D video game you've ever played? Today, we're going to build all of trigonometry from scratch. 1 triangle, 6 ratios, 3 identities, and by the end, you'll see how they all connect into one beautiful system. And it's way simpler than you think. All right, let's set the stage. Picture a flat horizontal line. Call it OA. That's our starting line, our ground zero. Now imagine a second line, OP, pinned at O like the hand of a clock. Rotate it upward. Sweep it through some angle theta. Now freeze it right there. Drop a vertical line straight down from P to the ground, hitting point M. What you've just built is the most important shape in all of mathematics, a right triangle. 3 sides, the slanted line OP, that's the hypotenuse, always the longest. The vertical drop PM, that's the perpendicular. And the flat bit OM along the ground, that's the base. These 3 sides are the entire raw material for everything we're about to do. Now here's where the magic starts. Take those 3 sides and start making fractions. Divide one by another. You get exactly 6 possible meaningful ratios, and each one has a name. First up, sine theta. That's the perpendicular divided by the hypotenuse, PM over OP. Think of it as how tall the triangle is relative to its longest side. Next, cosine theta. Base over hypotenuse, OM over OP. How wide is the triangle compared to its longest side? Third, tangent theta, perpendicular over base, PM over OM. This one tells you the slope, how steep the triangle is. Now here's a neat pattern. The next 3 are just the flips. Cosecant is the flip of sine, hypotenuse over perpendicular. Secant flips cosine, hypotenuse over base. And cotangent flips tangent, base over perpendicular. 6 ratios, 3 pairs of reciprocals, all from one triangle. Now, there's a couple of bonus ratios that pop up in older textbooks. Versed sine, or just verse theta, is simply 1 minus cosine theta. Think of it as how far cosine falls short of 1. And coversed sine, covers theta, is 1 minus sine theta. You won't see these as often, but they're good to know. And here's something crucial that trips people up. Every single one of these 6 ratios is just a number. Not a length, not an angle, a plain number. A fraction of 2 lengths, which means the units cancel and you're left with a pure ratio. That's why they work universally. The triangle can be any size and the ratios stay the same for a given angle. Okay, now this is where it gets really beautiful. Let's take the Pythagorean theorem and apply it to our triangle. MP squared plus OM squared equals OP squared. That's just Pythagoras, nothing new. But watch what happens when we divide everything by OP squared. MP over OP, that's sine. OM over OP, that's cosine. So we get sine squared theta plus cosine squared theta equals 1. That's the first Pythagorean identity, and it might be the single most important equation in trigonometry. But we're not done. Divide the original equation by OM squared instead. You get MP over OM squared plus 1 equals OP over OM squared. That's tangent squared plus 1 equals secant squared. One more, divide by MP squared. You get 1 plus OM over MP squared equals OP over MP squared. That's 1 plus cotangent squared equals cosecant squared. 3 identities, all from the same Pythagorean theorem, just divided 3 different ways. Elegant, right? Let's see these identities in action with a quick check. If sine theta is 3/5, what's cos theta? Plug into the first identity. 3/5 squared plus cos squared theta equals 1. 9/25 plus cos squared equals 1. Cos squared equals 16/25. Take the square root. Cos theta is 4/5. And from there, every other ratio falls out. Tan theta is sine over cos. 3/5 divided by 4/5. That's 3/4. The reciprocals? Cosec is 5/3, sec is 5/4, cot is 4/3. One identity, one known ratio, and we've reconstructed everything. Now let's talk about limits. What values can these ratios actually take? Think about it geometrically. The perpendicular PM can never be longer than the hypotenuse OP, right? It's a side of a triangle. It can't outgrow the longest side. So PM over OP, sine theta, can never exceed 1. Same logic for cosine. The base OM can never be longer than OP. So cosine is also trapped between -1 and 1. And if sine and cosine max out at 1, then their reciprocals, cosecant and secant, must be at least 1. You can't flip a fraction that's at most 1 and get something less than 1. Tangent and cotangent, though, they're the wild ones. They can take any value at all because the perpendicular and base have no fixed relationship to each other. Tangent goes from 0 all the way to infinity. Let's bring it all together. We started with one right triangle, 3 sides, 1 angle. From those 3 sides, we built 6 ratios: sine, cosine, tangent, and their reciprocals: cosecant, secant, cotangent. Then we took the Pythagorean theorem and divided it 3 ways to get 3 powerful identities, the most important being sine squared plus cosine squared equals 1. And finally, we discovered the natural boundaries. Sine and cosine are locked between -1 and 1, while their reciprocals live outside that range. 1 triangle, 6 ratios, 3 identities. That's the foundation of all of trigonometry, and everything else builds on exactly this. If this helped, smash that like button. Subscribe and turn on notifications for the next video, where we'll use these ratios to find exact values for special angles: 30, 45, and 60 degrees. Drop a comment. Which identity surprised you most? See you in the next one.